All right, so now that we've gone over how to write the names and write the formulas for ionic compounds, let's talk about molecular compounds, right? That is, compounds that are made up of molecules with only covalent bonds. So, whenever you have a compound made up of only nonmetals, you know it's a molecular compound. So, when we see formulas, usually the element that's the leftmost on the periodic table goes first. Leftmost meaning, lowest electronegativity. Okay. H might disobey this, right? But besides H, the least electronegative comes first in the element. So when we name these, we're going to use prefixes. And this is the primary difference between ionic naming and molecular naming. Because in ionic naming, charges are important. You have to look up charges. With molecular compounds, you're not going to look up any charges at all. Okay? Don't look up charges. We don't use them here. We're going to use prefixes. So, what are the prefixes? Here they are. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, right? You've seen these in geometry, although I think in geometry, hepta is septa instead, right? But other than that, I think they're the same. So, to name a molecular compound, you simply look at the formula, at the subscript, and you use the appropriate prefix. Okay, so N2O5, dinitrogen, because di is the prefix for 2, pent, because pent is the prefix for 5. Dinitrogen pentoxide. The second, there's a 2 on nitrogen again, so this is going to be dinitrogen. And there's only one oxygen, so the prefix for 1 is mon. So dinitrogen monoxide. Now here's the thing. There's something special you should know about the prefix mono. And that is, this prefix is only used for the second element. Okay, it's only used for the second element. We never use it for the first element because it would increase the number of chemical names by a lot, unnecessarily. So for example, NO2, well, the name for NO2 is nitrogen dioxide. Okay? It's not mononitrogen dioxide. We don't use the prefix mono on the first element. Right? Here's another example. CO2. What's the name of CO2? We've mentioned it many times, even before we got to this unit. It's carbon dioxide, not monocarbon dioxide. Get it? You don't use mono for the first element. You only use it for the second element. And do you see how we named this without looking up any charges? It's because the molecular compound naming system does not involve charges, just the prefixes. Here's one. How do you name that? Carbon monoxide. Not monocarbon monoxide. It's just carbon monoxide, right? Again. Okay, so here we have some examples. Let's go through and name these using the prefixes. ASCl3. Ogen. Yep. Arsenic trichloride. What about B? Someone I haven't heard from in a while. Let's see. Olivia, what do you think B is?
Sulfur hex fluoride.
Right, sulfur, and we use hex, we add the A, hexa fluoride, and that's another thing to discuss here. So notice on these prefixes, guys, see how these A's are in parentheses? Those A's in parentheses are used only if needed. And what I mean by if needed is use the A if the element name begins with a consonant. Okay? So if we look at this example, fluorine is a consonant, so it's sulfur hexafluoride. F is a consonant, so we add the A. But if it was oxygen, oxygen begins with a vowel. So we would just call it hex oxide. We don't add the A if the element name begins with a vowel. Now, this is a minor point. It's not a big deal. You're not going to lose points over anything like this. But I'm just kind of explaining how and why the A is used, okay? Not a big deal. Okay, PCl3. Amanda, what do you think? How would we name that?
Phosphorus trichloride.
Yes. Okay. Yeah, Ojan. Next one, yeah? Change the ending. Right. Tetraphosphorus heptasulfide. Okay. What would the next one be? Julia, what do you think the next one would be? So you have iodine, and you have two of them. So diiodine, okay. Change the suffix. Change the ending. Pentoxide, yes. Diiodine pentoxide. Yeah, Nick.
Do you separate the di and iodine?
Oh, I didn't mean to. I just kind of, yeah, not necessarily here. Just scooches. Here we go. All right, and the last one, Angelica. What do you think the last one's going to be?
Xenon tetrafluoride.
Right. Okay. So naming molecular compounds, when they're all nonmetals, this flows a lot faster because you don't have to look up any charges. You don't have to make sure things cancel. You just literally look at the subscript and you just write the right subscript. Okay? All right. So we covered that part. We already did a bunch of naming. Oh, okay. Here's something we need to do. We did a little bit at the beginning, but let's wrap it up by finishing up by doing this again. Write the formulas for the following. So in order to write the formulas, remember, if it's ionic, the charges must cancel. And these examples here are all ionic. So you got to look up the charges. You got to make sure they cancel. What would the formula be for lithium and nitrogen combining? Start with the charge on lithium.
1.
Yes, it's a 1. Charge on nitrogen? -3. So how do you make that work? Li3n. Okay. Charge on aluminum? Charge on sulfur? Okay. So these two don't cancel. You have to multiply them somehow. So they cancel out.
Al2S3.
Yes. And here, maybe this helps to write it this way. 2 times positive 3 plus 3 times negative 2 must equal 0. The charges must cancel, right? So that's kind of one way to help you figure out what to multiply by. If you want to think about it mathy. If not, it's okay. Cobalt 2 chloride. Now, the charge for cobalt is being told to you. It's literally right here. The Roman numeral 2 tells you the charge on cobalt is 2. So you just have to look up chlorine.
That's 1. Should be
Oops.
cobalt. Would be cobalt CO2.
Nitrate. What's nitrate? Yeah, Casper.
For C, would you have to include the charge on cobalt?
Include the charge in formulas we don't write the charges. Like we just have to make sure that they are neutral. What's charge in nitrate? It's -1. Okay, so iron, it has a charge of +3. Nitrate, which is NO3, if that has a charge of -1, how do we fix this? Parentheses, and then what subscript do I apply to it? Yeah, 3. Okay. Magnesium permanganate. That's a mouthful. So magnesium is an earth metal. So that's how I know automatically it's +2.
And then the other one is 1.
It's -1. So the thing is, the formula is MnO4 with a -1. So I'm combining these two things. Kristen, what's that going to look like?
Magnesium and so
Let's slip some parentheses in there. There we go. How are we doing? Okay. All right. And so the last thing, the very last thing, I said that before, but I mean it now. The last thing is writing formulas from molecular names. And this is just as easy as writing the names from molecular formulas because, again, all you have to do is interpret what the numbers are. So, sulfur hexafluoride, there's only one prefix here. It's hexa.
6.
So it's going to be SF6. Diphosphorus pentoxide. There's 2 prefixes here. There's a di and there's a pent. So, okay, well, the di is attached to the P, so that's P2. And the pent is attached to the O, so it's O5. Okay. So, we are going to stop there.